This is a homework question that was sent to me from a student. This particular question is from section 1.8. And what we have here is a rational function. And we are asked to find the second derivative. So when I see this, we are asked to find the second derivative of this function. So there's my highlighter there. So of course, to find the second derivative, we first need to find the first derivative, right? We need to derive this function twice. So then the question is, well, which rule do we use here? So because we have a rational function, I have that numerator and that denominator. That's a giveaway that we want to use our quotient rule. And just as a reminder, let's see if I can change the color of my pen. So if I were to label the numerator as n of x and the denominator as d of x, then we would say that we would find the derivative by multiplying d of x, so the bottom, times the derivative of the top, so n prime of x. So the bottom times the derivative of the top minus the top times the derivative of that denominator all over that denominator squared. So that's the rule that we're going to use twice, okay? So let's do that. So what I would do is I will color coordinate this for you guys. So we will use purple to find the first derivative. So the first derivative will be the bottom, which is my d of x, which is that 2x plus 3. So that's the bottom, times the derivative of the top, which is 3, minus the top, times the derivative of the bottom, all over that bottom squared. So technically that is my answer. That is the derivative there. But what we want to do is we want to expand that numerator. We want to multiply everything out. Then we want to combine like terms. So if I do that, what would that look like? So I have 3 times 2x. That gives me 6x. Then I have 3 times 3, which gives me 9, and then I'm going to wrap that in parentheses just to help it look uniform. So I'm going to leave that minus there between the parentheses for now. But now what I want to do is multiply everything I have there by that 2. So that gives me 6x minus 8 all over that denominator squared. Now from there, I can combine like terms, and what I notice right away is I have 6x and 6x. Those cancel one another out, and then I have 9 minus a negative 8, which is the same thing as 9 plus 8, which gives me 17. So I have y double prime is equal to 17 over 2x plus 3 all squared. Oh no, apologize. I don't know why I did that. I'm jumping. It's y prime is equal to 17 divided by 2x plus 3 all squared. But again, if you refer back to the problem, it wants me to find double prime. So I need to find this thing one more time. So let's use a different color. We can use blue the second time. So to find the derivative this time, we're going to do the same thing. So I'm looking right here. So the second derivative is going to be found by taking that bottom, so that 2x plus 3 squared, times the derivative of the top, which is 0, minus the top, times the derivative of the bottom. Now, when I find the derivative of the bottom, now I have got to use my chain rule. Okay, so that means I bring that, let's put that in parentheses, bring that 2 out front. We're going to leave the inside the same. If I subtract 1 from 2, that leaves me 1, so I don't have to write an exponent there. then times the derivative of the inside, which is also 2. And then, so that's the top times the derivative of the bottom. Then we're going to divide it all by that denominator, so 2x plus 3 squared. Then we're going to square that, so that will become to the 4th power. Okay, so now if you look, this 0, we just cancel all of that out. It's gone. So what I'm left with up there is 17 times 2, which is 34, and then 34 times 2, which is 64. So that leaves me with a negative 60. Let's see, 17 times 2 is 34, times 2 is 68. I apologize. That's a negative 68 times 2x plus 3 divided by 2x plus 3 to the 4th power. And I think once I write it that way, you guys can see that I have a common term in my numerator and in my denominator. So I can reduce this. I can take 1 out of my numerator, take 1 out of my denominator. That leaves me with a negative 68 divided by 2x plus 3 to the 3rd power.